Welcome, everybody, to this fireside chat. I'll be your host, Marlon Ruiz. Super excited today to announce our guest, who is Sergey Nazarov from Chainlink. Welcome to the chat, Sergey. Thank you for joining us. How are you doing today?
Yeah, doing well. Thank you for having me. Glad to speak with folks at Google. Great. Let's jump in.
Sounds good. We usually like to start with how you got into crypto, your aha moment. I know that you've had smart contracts for a long time. That website goes back a long ways. Can you tell us, how did you get interested in this and a little bit about your journey?
Sure. So I got into blockchain stuff around late 2010, early 2011. And there were like three main groups of people, and there was only Bitcoin. So there was no concept of blockchains. There was just Bitcoin. There were three main groups of people that were involved. There were the people who were building the thing, the cypherpunks, and like the people actually making the software. That was a very small community. There was a speculative community, and then there was the gaming community. And I came from the gaming community, basically. And some of the first people that mined a decent amount of Bitcoin were people who had GPUs from gaming, and they understood Bitcoin to be a type of digital currency, kind of like, wow, gold or something like that. So I actually just got interested in it from that point of view initially at the very beginning, because I thought I could use my GPU, my excess GPU cycles to get some kind of digital currency. And I was just interested in that. And then I started trying to understand what Bitcoin was, because it wasn't really attached to a game, right? It was just like, it was like some kind of digital currency without a game that came out of my GPU. It was kind of odd. It was atypical. And so I couldn't really understand what was going on. And then when I actually started digging into it, a lot of the properties of Bitcoin became much clearer to me, which are basically that it's a kind of resource that can't ever go down, and it's a digital currency that can't go out of existence. So those were two things that were very interesting to me, because if you know something about the history of digital currencies, like even going back to the early 90s and stuff, like there are these things called beans, B-E-N-Z. There's like a whole bunch of digital currencies that tried to get started in the early internet. And their consistent problem was that the rules of the currencies would change, like what you could redeem them for. So they had no global market where they had real value. And the entities that made the digital currencies always like ended up shutting down, basically. So there were all these people that did whatever they did to get the currency, but then the company, the tech company making the digital currency, would shut down. And when I realized that Bitcoin could never be shut down as long as I and one other person ran a full history, a full Bitcoin node. And so like the longevity of this digital currency could literally be hundreds of years, possibly. I kind of got very interested in how that was even possible. And so I started digging into it, and I started mining it more. And I began mining more and more, because all you could really do back then was mine or accept Bitcoin. Like there wasn't really any way to build applications on top of Bitcoin. No one really was really doing that. And then what happened was people started making the first what were called altcoins. So alternative coins, or they were called app coins. Those were the two names for them, app coins or alternative coins. And those coins began to fork Bitcoin or do other things. One of the first ones was Namecoin, which had a name system for like a decentralized kind of DNS system. And then there were others that had functionality. And I was building a number of different applications at that time that I don't think were really that interesting. But then when I started trying to build those applications in a decentralized way, they actually became very interesting. So like if you take something very basic like text messaging, one of the first applications that I actually worked on was something called CryptoMail, where you were able to encrypt plain text, but you never had a server that held the plain text or the ciphertext. That was always held on a chain. So there was like this problem at the time where there were all these centralized messaging systems that were trying to basically make it so that you could send text messages without any central repository where somebody could get access to the unencrypted plain text. And they were like bouncing up against all these weird systems and all these like triple encrypted things. It was like really tough for them, basically. And then in a number of weeks, it was really interesting that I and a few other people were able to make something that solved that problem better than people that were much more experienced and much more advanced in their thinking, basically because we had a decentralized infrastructure. And then I started asking the question, well, what else can a decentralized infrastructure make very reliable? And the answer is like basically all digital transactions, period. That's what I eventually came to. But when you realize that the guarantees that decentralized infrastructure offers extends beyond the one or two use cases where you get going in this industry, it kind of becomes very interesting, because you realize that all digital relationships can become guaranteed. Those can be ad network relationships, they can be trading relationships, they can be insurance relationships, whatever digital relationship you have. And then the really interesting thought actually is, if I were to give you a Web2 application, if I were to give you an application that had all the same cost and usability and features of a Web2 application, but then I were to give you a Web3 version of it that had this guarantee that the application could never deviate from your expectations, it could only operate within the scope of what you expected, why would you ever use the more risky Web2 version of that application? And I could just never come up with an answer to that. Like, I could never, no one so far has told me, if you give me the exact same usability, cost, speed, interface, I will take the more risky thing rather than the Web3 thing that can't be manipulated. And there's a lot of like recent stuff that just proves this to be true, because now if you ask people, if you could have a bank that you couldn't be in a situation where your deposits weren't accessible to you, would you choose that bank over another bank? Like today, people are, yeah, that sounds like a really nice feature. Like a month ago, they'd be confused why you're asking them, right? They'd be like, why are you asking me whether I can access my bank stuff? My bank stuff is good. It's all good. And so that's, I think, what people don't fully realize, that I and a few other people in our industry have realized. It's that you can actually just take every single digital interaction and you can turn it into something that's guaranteed, rather than something where you have to rely on somebody's promises, something that I call brand promises. And so when I realized that, I think I realized that more around, like I was really, really convinced of that around 2014. I just became completely convinced of that dynamic. Yeah, once you become convinced of that, it's really kind of tough to wonder how this isn't going to become the way that all digital information, digital transactions, digital relationships work. The challenge is really just making them work that way, right? Which is the challenge that I'm working on, which is the challenge I know some people at Google are working on. But I'm yet, after over 10 years of working on this with various people, I'm yet to meet someone who can explain to me why they would take the riskier version of an application if they could take the de-risked one. And so I'm continually convinced that that makes a lot of sense.
Yeah, that's a really wonderful point that you have, because if people don't understand why they need it, then they're just going to say, oh, I don't care about that. And just in the short time frame you mentioned, already people are starting to understand that. And kudos to you and the rest of the folks in the industry who really saw this so long ago. And then, good for folks that are learning it now, because it's never too late to learn. So I appreciate you sharing that particular, story. And I think it will resonate with folks within our community and everywhere else. I mean, imagine not being able to go to your bank and take your money out, right? definitely not a situation that anyone would want to have. Perfect. So as we like to educate folks, let's transition a little bit to Chainlink itself and the creation of Chainlink. I've been following Chainlink for quite some time, and the thing that I first learned about it, it's an oracle, right? And that's a really key topic. Can we peel that back a little bit and kind of explain to our community and the rest of the audience, like why did you create Chainlink, and what is an oracle, and how does that kind of connect together for us?
Sure. So smart contracts for me were always things that could automate important things from the real world. Smart contracts for me were, when I got into working on smart contracts, when they were starting to get going in this industry, and the concept of smart contracts and Ricardian contracts predates blockchains. And it really came out of, the digital world that Web 1.0 made. And it really had a sense of automating things, basically contractually automating things. But when a lot of people after me got into the industry, a lot of their tutorials and a lot of the things that they understood smart contracts were they were like these tokenization machines, right? So what's a smart contract? It's a thing that makes a token. It keeps track of a ledger. It does all these types of things. That's not really how I got into this. So from the very beginning, the idea of a smart contract to me was a connected, hyper reliable automation engine. That's what it was to me, right? And if you think about the semantics of smart contract, it makes sense, right? Because they're smart homes. So connected, automated homes, smart cars, connected, automated cars, smart contracts, connected, automated contracts. Makes sense, right? And so the types of contracts that I was building and we were building even before things like Ethereum existed were these types of connected contracts that weren't just containers for state and tokenization. So if you look at what a smart contract is in how it's defined now, it's basically a state machine on a blockchain that can do three primary things. It can act as a private key infrastructure, it can create token ledgers, and it can be a state machine where you can define various conditions around, those tokens or some other set of conditions. What smart contracts don't do is they don't interface with the outside world. So they're actually a little bit weirdly named because the idea of smart implies connectedness in the more traditional kind of like Web 2 world, right? Connected homes, connected cars, smart homes. But I always saw them that way. So the very first versions of smart contracts that we were building were connected. And what we had done without like fully realizing it actually is build an Oracle infrastructure. And what an Oracle infrastructure is it's a way to connect inputs into a system that doesn't have those inputs. Right? It doesn't have some critical input. And in some cases, the ability to create a critical output. So what oracles do is they provide the additional ability for smart contracts to meet that smart dimension of being connected to things. And the reason that we were working on oracles more and more, frankly, is because Ethereum did a really good job at capturing a part of the stack. So basically what happened was we initially had a full stack solution, which had an engine for the state and had that used another chain other than Ethereum, and then we had an Oracle system, and then we had an interface. And that's what smartcontract.com was. It was this kind of interface where you could go and you could make this connected smart contract. One of the first smart contracts, funnily enough, was around search engine optimization, where we allowed people to put down a deposit that a search engine optimization firm would get only if they raised the ranking of the URL for a specific keyword. And the reason we made that contract was because there was like a lot of fraud and dispute in the search engine optimization world, because people would promise to raise the ranking and they wouldn't, they keep the money, or the people who promised to pay them to raise the ranking would realize it's the wrong word or the wrong thing that they wanted to raise, and they wouldn't pay the SEO firm. And so we used the blockchain as a kind of smart deposit mechanism, right? Where you could put a deposit and then the oracles would verify if the ranking of the URL was on a certain level for the search term actually on Google. And the reason the oracle could do that is because it was very public information, right? It was very easy to verify that. And so oracles for us initially were just an obvious component of a smart contract. Then Ethereum did a good job at basically taking a part of the stack, which I would call the kind of blockchain part of the stack, the state machine part of the stack. And then we decided that we don't really want to compete with or kill Ethereum or do anything like that. You know, we were excited about what they were doing and we thought they were doing a good job. And we decided that the oracle part of the stack was quite interesting because we already knew from the many years of building smart contracts that without oracles, you really wouldn't be able to do much more than tokenization of some type, movement of tokens, trading of tokens, and maybe the definition of some conditions, but everything more advanced, like financial products, insurance, all kinds of advanced gaming, like more advanced use cases would all require an oracle mechanism. And then we began with a more centralized oracle mechanism. But then when you think about it, a centralized oracle mechanism doesn't really provide you much because it doesn't really deliver on the deterministic promise of smart contracts, right? And the promise is that you have an agent, a technological agent that will, in a guaranteed way, execute your contractual relationships. And so what oracles do is they feed that agent very, very important inputs without which the agent can't resolve the contract. And so if it feeds the agent the wrong inputs, then the contract gets resolved incorrectly. So you could, with a centralized oracle, pretty much control a contract. And that's not really the point, right? The point is so that you have a decentralized, truly deterministic, truly reliable contract. And the challenge is, how do you take things that aren't as deterministic as we'd like them to be, like market data or weather data or identity stuff or various other inputs, and how do you make those inputs meet that standard of highly reliable deterministic contracts? And so that challenge very clearly required decentralization. And so that's where the idea of an oracle network was born. It was born out of this desire to not only provide data or information or inputs or even outputs, but to provide it in a way that the inputs and outputs could be guaranteed close to or at the same level as the smart contract state. Because only then would you really make something that was truly reliable in this cryptographically guaranteed manner that we were seeking to create. And that's what Chainlink is. So Chainlink is the leading, and I think the first real oracle network that basically invented and introduced this method of consensus. And the thing that our industry really uniquely generated from a technical point of view is consensus, right? It's the ability to guarantee things because consensus verifies it enough times with enough independent systems to make sure that it is immutable, ungameable, and guaranteed. And so blockchain consensus, once again, relates to private keys, token ledgers, and state machines. And Oracle network consensus relates to everything else. So Oracle network consensus relates to data, identity, random numbers, external payment systems. Basically, anything that can be proven through consensus will be proven with an Oracle network that focuses on generating the very specific type of consensus that needs to be generated to prove that thing. And we've been able, in the Chainlink ecosystem and the Chainlink network with us in the community, have generated over 1,000 of these Oracle networks, which basically means there's over 1,000 of these distinct services which generate consensus on specific topics that are critical for enabling things like DeFi. And just to put that into perspective, DeFi was well below $1 billion when we got started. And then it grew to well over $200 billion. And we were powering anywhere from 70 to 90% plus of DeFi. And today we power anywhere from 60 to 80% of DeFi. because DeFi, decentralized finance, is basically that combination of state on a blockchain and Oracle network consensus about data combined to make a financial product of some kind. And the nuance there, once again, is not that you just have a financial product, but that you have a decentralized financial product. And what that means is that it should be beyond the reach of certain failure modes. And there should be certain levels of transparency and risk management that centralized financial products simply don't have, which over time continues to be more and more true. But that's kind of the general idea.
Cool. Thank you. 1,000 networks. That's a lot. I can't imagine what it'll be in 10 years from now. That's crazy scaling challenges that you'd have to face for sure. I've often seen that, Chainlink is considered a Web3 services platform. I'd love to understand that, because I've always thought about it from the Oracle perspective, but if you could share with our community what exactly, is meant by the Web3 services platform, that would be super helpful.
Sure. So the consensus I just described was initially applied to market data, which gave rise and accelerated the growth of DeFi. But really, that consensus method is applicable to many, many things beyond market data. So it's applicable to something called proof of reserves, where we prove the solvency. We prove the balance sheet of different off-chain systems. It's applicable to automation. It's applicable to something called functions, which I think is now being more and more applied to gaining access to various Google GCP services. And it's actually applicable to cross-chain messaging and even random numbers. So the reason it's a services platform is because it's not just about data, it's about basically all the compute and all the connectivity, even cross-chain connectivity, that you could want in what's called a trust minimized form. And trust minimization is really this method of making sure that the system is beyond the control of others, and it's beyond the beyond certain failure modes, basically. So it's a platform because it's moved very far beyond market data. It's the leading way to do automation in many cases. It's the leading source of random numbers in the blockchain industry. It's the leading source of many things on many chains beyond market data. And so it's just kind of like the consensus can do many more things than data, so it's a platform, is the reasoning there.
Okay, that makes sense. Appreciate that. As you've been, working on Chainlink for so long, like, what is the goal of Chainlink? What kind of world is Chainlink aiming to enable? Like, where do you see yourself going in the future, for Chainlink? And what does that world look like?
I think it's always been weird for me that people can renege on their promises and institutions can renege on their promises, as we've recently experienced with certain regional banks, and has happened historically with other big entities like Enron and Lehman and a whole bunch of others. That's always just been very odd to me. It's also always been very odd to me how certain emerging markets don't have legal systems that allow them to have, working contracts. And so those are the two things that I think would be very, very good to solve. So it'd be very good to have the global financial system work in a way where certain risks and certain violations couldn't happen, because they were written and they were run in systems that simply, at a very fundamental base level, made those failure modes impossible. And those failure modes come in like waves. They go from, hey, I don't really care about that failure mode because there's a lot of cheap money and everyone's making money and no banks are failing and we're all happy. Right? That's like a couple of years ago. And then, a couple of things go wrong and everyone starts going crazy and it's like, oh my God, what's going on? I thought the world worked a completely different way. And the thing is, it really should work a different way, right? It really should work in a way where these types of events, where large entities renege on their obligations, really shouldn't be able to do that, not from like a contractual point of view, not from a legal point of view, but from a physical and technical point of view. Like it just shouldn't be possible for them to do that. And then the other thing that's very interesting is if you make a system of contracts that isn't as probabilistic and doesn't rely as much on other people making decisions, you basically arrive at a world where even if you have very broken local legal systems in various countries, it doesn't matter. And one of the really good examples of this that I like is crop insurance, where there's places in the world now where they might not have a working legal system to allow good insurance companies to show up and offer crop insurance. But because they have a $50 phone, they're able to access smart contract crop insurance. And then the Oracle networks and systems that we make verify weather, and that feeds into a state machine on a blockchain somewhere that basically makes the payout happen. And that form of crop insurance is actually even better than the crop insurance you have in developed economies with working legal systems. So the thing that I'm probably most interested in actually is that leapfrogging. So that on the one hand, it's great if the global financial system works in a certain way, and that's the sense in which this technology relates to hundreds of trillions of dollars in value, which it does, and which hundreds of trillions of dollars in value will be formatted into this format. But then I think that'll give rise to a whole bunch of systems that really can't be defrauded, and so your local legal system doesn't matter anymore. And that'll actually be very powerful, because people without legal systems will be able to leapfrog that problem, just like they leapfrogged from not having paper libraries to reading the same Wikipedia article that I'm reading. And that's going to be pretty interesting, in my opinion.
Yeah, I like the way you said it earlier about transformation. I mean, pretty much everything we do, no matter what it is, needs to be transformed. I used to joke about it, say, oh, we're all in the digital transformation. But with these topics, it's like a real thing, and it actually can change the world. So that gives me a lot of hope. Thank you for sharing that perspective. I wanted to circle back to something you mentioned a little bit earlier, proof of reserves and Chainlink Functions. I know that Chainlink Functions was recently announced, so that's pretty exciting. And then I think of proof of reserves and what happened with FTX. Can we talk a little bit about that and your perspective on what Chainlink Function brings and how proof of reserves could have, saved the day or can save the day in the future?
Yeah, so the exciting thing about Chainlink Functions is that you can access multiple services that you couldn't access before in a number of minutes, including certain Google services, certain Google data sets, and so on. And that's something that Alan Day has done a great presentation on recently that people can look up and find. And it's been great working with him and other people at Google on making that possible. I think that the thing that Chainlink Functions will really do is it'll increase the breadth of what developers can easily access, and it'll increase the combinations of things they can combine into more advanced smart contracts. Proof of reserves is actually a very unique focus service on proving the balance sheet and the assets of a certain protocol or of a certain system. And the way it would have solved things like FTX is that it would have just continually informed people about what the balance sheet was. And we're seeing a huge amount of demand for proof of reserves since FTX, because people that make these systems now have reached a point with their users where their users demand proof. Their users are no longer content to simply wait for their brand to claim that everything will be okay. That's not good enough anymore. And because that's not good enough, there need to be systems that prove those things. And proving those things is what proof of reserves does. It proves the reserves. Now, there's other notions of proof of, like proof of solvency, proof of liabilities, all of which we're working through and planning to offer at some point. But the interesting thing about proof of reserves is that it's a very specific type of cryptographic truth that before something like FTX wasn't particularly relevant, and after was extremely relevant. And I think you're going to continue to see a similar dynamic as more and more traditional systems have failures, even like the banking system recently, where people are starting to think about where, well, maybe I should have a portion of my value in something with a private key attached to it so that I could access that value in any scenario. Because scenarios that I could previously not imagine seem to happen in 24 to 48 hours. So I think that's kind of the pattern we're going to keep seeing, is that there's going to be some kind of issue. It's going to be a crisis of faith in the system that has that issue. That system is going to want to restore faith, and it's going to choose to do it in a cryptographically guaranteed way. And that's really what Chainlink does, is it provides the infrastructure to restore faith by cryptographically guaranteeing various things. And that could be like anything from proving the reserves, proving the assets, the liabilities, proving that the data used to compute certain outcomes in the application are beyond the control of the application creator, cross-chain things through something like CCIP, and making sure that those dynamics work properly. So it's really a very wide array of trust issues that initially seem irrelevant, but then become extremely relevant in 24 to 48 hours. And that's really what Chainlink and blockchain infrastructure does, is it creates this cryptographically guaranteed version of applications. And that's kind of what we're accelerating with functions and with CCIP and with proof of reserves and with data and with automation and all the various aspects of the platform.
Yeah, the cross-chain CCIP is interesting to me because in the early days, it seemed that everybody didn't want to play along and work together with different chains. And they said, well, live on my chain or don't live on any chain, kind of a thing. So it's really, I think, a good sign for the community that folks like yourselves are looking in, how do we operate across chains and consider these kind of concepts, because people want to move their assets wherever they want to move them. They don't want to be constricted. So I think that's a great thing to think about for sure. I'm going to pull a thread a little bit on Web2 and Web3. When you were talking about, hey, why would I want to be in the old way versus the new way? I think one of the really important topics is, how do you transition between the two, and how do these things complement each other between Web2 and Web3? So what do you think the biggest opportunities are for, Web3, enterprise opportunities, as well as, combining the two, living in a world where you're part Web2 and part Web3, in the future, in the near future?
Yeah, sure. So there are a lot of DeFi applications that are moving faster than traditional banks. Traditional banks are starting to slowly move. And so there's these two kind of worlds. There's also a third version where you can just add a component, a Web3 component, to a Web2 system and make it more reliable. We see a number of Web2 systems adding, data and other things that are cryptographically guaranteed by Chainlink networks to make their system more reliable. So there's this kind of world of startups. Then there's the enterprise capital markets / institutional world. And then there's the Web2 application world, where you could add on various cryptographic guarantees through decentralized infrastructure. Those are basically the three directions. I think all three of those directions are fruitful. I think it really depends on, well, I mean, it depends on how much value flows into the public blockchain economy versus the private blockchain institutional economy, versus how many things fail and Web2 applications want to prove things to their users. So like one good example of the third one is, before, text messages weren't end-to-end encrypted, but now they are, right? And everyone uses things that are end-to-end encrypted. That's an example of the third one, where end-to-end encrypted technology was suddenly valuable because people didn't trust entities with their messages anymore. The institutional one really depends on institutional adoption, which is slowly happening. And the DeFi and startup one kind of depends on how much money flows into the blockchain industry. And if a lot of money flows in because people want to use DeFi or they want to get NFTs or whatever, then those startups kind of go up and to the right. And therefore, that becomes the way that people interact with this. It's really been between those three. It's not clear which one of them is gonna shoot out first. From our point of view, we're just doing all three. We're powering the vast majority of the blockchain applications that are more advanced, that need things like market data and random numbers and so on. We're working with a lot of top banks and large global market infrastructures in very, very interesting and increasingly advanced ways that I think will at some point have a real path to go into production. And then we are also working with various Web2 systems that want to have an additional guarantee without completely rewriting their whole system in a blockchain somewhere. So those are the three, and all of them I think will happen at their own pace. One of them will shoot out, and then it might calm down. Another one might shoot out and calm down. But I think all three of those will continue to happen.
Okay, yeah, I think that's a really important subject. I feel that we're going to be in this middle ground for a long time. So however we can bridge the gap can allow more enterprises to get involved and more people to get involved. Really cool thinking on that. Thank you for that. Okay, I guess one last question before we move on. I'm just going to ask real quickly, how and when do we get to become mainstream with crypto? I've been in this for, obviously less time as you. You keep plugging along, so that's great. But like, when do you think we hit critical mass on that S curve? Do you think that's, just a general question, I guess. When do you think that happens, and what does it take?
Well, those are two very big questions. So on the first question of when do I think it's going to happen, I don't really know, because I am consistently overly optimistic. It's March. In March of every year for the past 5 years, basically same thought process. This is the year, DeFi all the way, smart contracts all the way, institutional adoption all the way. That's March. By the middle of the year, start thinking, well, why hasn't it happened yet? Towards the end of the year, it's like next year's the year for sure. So I'm generally skeptical about a number of ideas because I really want to test them and I really want to make sure they have merit. But on this question of when adoption will happen, I'm just consistently overly optimistic. So I'm not really a good barometer for that. You can ask me this same time next year, I'll tell you the same thing. That it's like this is the year. In terms of what needs to happen, there are about 4 very key problems that need to be solved. First problem is scalability. So the systems can hit the throughputs that people need for real usage at scale, like gaming and trading and all this stuff. Second one is connectivity. So the systems can be interconnected with existing data sets, existing backends, existing everything. That's the problem we're very focused on. Third one is privacy. People really are used to privacy and expect privacy, and many institutional cases need privacy from a legal point of view. We also work in that realm, and we have a number of zero-knowledge proof things that make privacy much easier and actually quite possible for many situations that previously are not historically possible. And then the final one is usability, where the private key storage, private key management, private key security dynamics are not good, right? Like the average user can't really deal with private keys very well still. It's not a solved problem. They have to keep a seed phrase. There's no mobile hardware key store that can just abstract away this problem. Key recovery is a huge problem, right? So if you even had a hardware key store on a mobile phone and you lost that mobile phone fishing or something and it fell in the river, like, what are you going to do? You just lost your life savings. It's not a solved problem, right? So those 4 problems getting solved, eventually that all kind of like you have an intersection of those problems being solved enough. And then the developer explosion comes, the developer kind of like, let's build everything that we wanted to build over the last 10 years in 2 years. And then you have like Uber-like and Netflix-like and eBay-like use cases appear overnight. And then it's obvious, right? Then, wow, how obvious? Why didn't how could we think that anyone would want an application that could screw the user? Why would anyone ever want that? Obviously, everyone wants applications that, you know, they have a level of control and reliability from, and that's obviously what all applications should be. But how quickly that happens, I don't know, unfortunately. But it also doesn't matter because I'm just going to keep doing it.
I love your optimism, you know, and I think that to be in this space, you really have to have optimism because there are so many ups and downs. And I love that you reset your clock every March and you're like, this is the year. And I don't care what happened last year, but this is the year. So appreciate your optimism for the community and what you do in that respect. So really appreciate you joining. And I think it's been a great chat. Looking forward to seeing, you know, what comes next for you as well.
Great. Thank you. Thank you for having me.
Perfect. All right. Thanks all.